Hello, thank you very much for coming. My name is Jeremy Lewi. I'm an engineer at Google, and I'm leading the team at Google that's contributing to Kubeflow. And so this session is going to be a deep dive into the Kubeflow project. So it's going to be focused a little bit more on the details of the project, and it's sort of aimed and tailored to contributors or people that are thinking about contributing to the project. So there are, though, a number of talks at KubeCon related to Kubeflow, or some of the components related to ML. So if you're looking for an introduction or that's more focused on sort of the user experience, you should check some of those out. Some of those haven't happened yet, but for the ones that have happened, like the introduction yesterday to Kubeflow, you can find the slides or the talk online. So just a brief agenda for what we're going to talk about today. I'm going to start just by giving an explanation so we're all on the same page of what is Kubeflow and what we're trying to accomplish. We're going to discuss a little bit the roadmap, and then I'm going to try to give my thoughts, at least on what I think are some core principles that we're trying to follow as the project, because we're growing rapidly, and I think trying to establish those principles and getting buy-in from everybody in the community is going to help us move together successfully. And then one of the questions we get a lot is why ksonnet? I don't even know if I'm pronouncing that right, so I'll talk about that briefly and how that fits into the project. So this slide illustrates the problem that we're trying to solve with Kubeflow. So one of the things that we've learned a lot at Google, having deployed a lot of ML systems in production, so as background, my first job at Google was working on the YouTube video recommendation system. And so this slide resonates a lot with me because what we found is that when you're deploying ML systems in production, you spend most of your time not on the actual ML code, which is this bit. So when we tend to think of ML, we think about the algorithms, the deep neural nets, and all the complex math that sort of powers them. But what we've actually found is that most of the time and energy that goes into maintaining systems and products is all the supporting services around them. So you have to do all of your data ingestion, your data cleaning. You have to manage resources for your serving infrastructure, your data processing infrastructure. You have all of the actual serving infrastructure. You have all of the monitoring to keep things up and healthy. And so what we've realized is that ML in production requires DevOps, and it requires lots of it. And so, as I think everybody in this conference can probably appreciate, containers in Kubernetes are really great at DevOps. And so we wanted to try to use containers in Kubernetes to solve some of the DevOps challenges of ML. And so the goal with Kubeflow is to build a Kubernetes native platform for ML so that we can make ML portable. And what we mean by portable is making it easy to move from local development on your machine into your staging or test clusters, and then finally into production. So what exactly is Kubeflow? First and foremost, we're a community. So we are a growing community of data scientists, DevOps engineers, software engineers, product managers. And as a community, we're coming together to build an ML platform and to build that ML platform on top of Kubernetes. And the reason that we're all coming together to build a platform is because I think there's a growing recognition that building an ML platform is a really big problem. And it's a lot easier to build it together as an open community and have everybody contribute to it rather than trying to build it all by yourself. And I think this is a lesson that we're taking from the Kubernetes community, where we've seen that Kubernetes was very successful because they built an open platform that brought a lot of people into that platform that contributed to it. And I think that's one of the main reasons why Kubernetes has been as successful as it is. So we're trying to recapture that magic. As I said before, Kubeflow wants to be a Kubernetes native platform for machine learning. And so that means a couple of things. First and foremost, we are taking advantage of, we run wherever Kubernetes runs, right? We're taking a hard dependency on Kubernetes, and that's because we're relying on Kubernetes to be the basis of our portability story, right? So Kubernetes runs locally on your machine using Minikube or now Docker. You can also run it in your on-prem clusters, and you can also run it in the cloud. So if you have a platform that runs on Kubernetes, then it's easy to move that platform and any products built on those platforms across those different environments. We're also taking advantage of Kubernetes functionality and APIs to solve some of the problems that you have in machine learning. So a particular example of that is a lot of your machine learning frameworks today, like TensorFlow, support distributed training, which is very important to scaling out and being able to train large models on large data sets, right? And so with distributed training, you often have to manage multiple processes. So in a distributed TensorFlow job, you have a master process, which is coordinating the training. You have workers, which are actually doing the actual work. And then you have parameter servers that basically act as a distributed data store for your parameters that you're learning. So we've started building custom resources to solve that problem and make it easy to manage all those resources, taking advantage of Kubernetes. And other companies like Selden have contributed custom resources to handle other problems like managing model deployments and rollouts. We're also following Kubernetes patterns. So we view ML as a set of microservices. And we're following that pattern, and we're also, taking a declarative approach to managing, infrastructure like Kubernetes does. And then finally, we package all this up together as ksonnet packages. There's a bunch of seats, up front, and you should feel free to fill in. And so, at its heart, what we're providing with Kubeflow is ksonnet packages that make it easy to deploy all these microservices in a way that makes them easy to manage together. And finally, we want to provide end-to-end machine learning solutions that are built on Kubeflow and illustrate how you can build products and solutions using Kubeflow. So as I said, first and foremost, we're a community. So we have about 70 individual members, and we have over 20 plus organizations that are listed there that have started to participate and contribute either as contributors or potentially as users to Kubeflow, and they span the gamut. So it's everybody from people that are, building, contributing machine learning code. So like Selden is developing code for handling model deployment. We also have contributions from, people in the more traditional DevOps space that are trying to take advantage of their tooling for things like monitoring and apply that to ML applications. And so there's a whole bunch of stats there. You can see that we're very active on GitHub. We have about 35 PRs per week, and I think an interesting stat is that we have 35 PR creators per week. So we have quite a few people. So that's way more than orders of magnitude. That's about an order of magnitude bigger than the largest teams working on Kubeflow. So any given company has about most 5 contributors to Kubeflow right now. So we're doing pretty well. And then we're taking advantage of the DevStats project from the CNCF for tracking all of our stats for our project, so you can get more stats online. So let's talk a little bit about Kubeflow as an ML platform. So if you're building ML solutions, these are all of the services you kind of need at a high level, right? So to start, you need services to do data ingestion, data analysis, data transformation. You then need to do actually train models using a framework like TensorFlow or PyTorch. You then want to be able to scale that out so that you can actually train at scale. Then you finally need to roll that out into production and serve those models. And then once you're serving those models, you actually need to monitor it and make it operational, right? So our goal with Kubeflow is really to fill in all of these existing boxes and provide a cohesive solution for using all these boxes together. And so then this is what the user experience looks like if you're actually trying to develop ML solutions and products. You sort of start by deploying Kubeflow on your cluster. You'll then typically do some experimentation and analysis to develop your model. So typically you might do that in a data analysis focused tool like Jupyter. You then would probably build Docker images and then use those Docker images to train at scale, which you might do using one of our custom resources for managing TensorFlow or forthcoming other frameworks like PyTorch. You then would probably want to build a model server to actually generate predictions, and then you can deploy that model, and then you have to integrate that model into your app. Maybe it's a web app or it's a mobile app, and then finally you have to operate that. So there's 2 types of components within Kubeflow. So there's first and foremost, those are the components being developed within Kubeflow. So those are ones that are sort of subject to Kubernetes governance. Kubeflow governance and being developed by the core contributors of Kubeflow. But then a lot of our components are actually existing components that are developed elsewhere, but are integrated into Kubeflow in order to provide that complete platform. And so these components are not maintained within Kubeflow. They're maintained outside. And so they're not subject to Kubeflow's governance. So you can, if you so choose, you can have maintain tighter control of your component, but still have that component be integrated and deployed as part of Kubeflow. And I'll have some examples on the next slide. So here's a list of the projects that are being developed within Kubeflow. So to start, we have a bunch of custom resources for several ML frameworks. So our TF operator is the most advanced. Our second up is probably our PY torch operator, which will probably make it into our next release. We also have a Cafe 2 operator that's in early stages of development. And then we're integrating other features. So the Uber folks have started contributing Horvad, which is a add-on to TensorFlow that allows you to run distributed TensorFlow using MPI. It's a way to do distributed training. The Intel folks have contributed KBC, which is a Kubernetes volume controller. And what this does is it basically moves data back and forth from, say, your object store to your nodes and caches it on your nodes. And the idea there is to manage data in a way that serves ML workloads efficiently. Then we have Katib. Katib is a hyperparameter tuning system. It's a clone of Vizier, Google's HP tuning system. The clone was not developed by Google. It was developed by some people, some contributors who have contributed it to Kubeflow. And then, finally, we're sort of closing some of the gaps around using existing systems. So as an example, we're providing Docker images for TF serving, which is a model server for TensorFlow, so you don't have to go and build those yourself. We're also providing curated Jupyter notebook images so that you can get some notebook environments out of the box. Here's a bunch of list of the different projects that we've already started integrating into Kubeflow, but are developed outside of Kubeflow. So Argo is a Kubernetes native workflow controller. So workflows are pretty important to writing data processing pipelines and ML pipelines. So we've started using Argo for that. We are also integrating with Jupyter Hub, which is a multi-user server for Jupyter notebooks. We integrate with Pachyderm as well. So Pachyderm is a package that provides a pipeline tool for running data processing pipelines. They also provide a data versioning system that's equivalent to Git for data. So that's a very nice tool as well. Seldon.io provides a custom resource and tooling for building and serving models in production. Tensor is a library of TensorFlow models and data sets that serve a variety of applications. TFX is a set of libraries coming out of Google that are part of their TensorFlow-based platform for ML. And so we've started incorporating those libraries as well. So we packaged TFMA, which is a model analysis package, in our curated notebook images. So let's take a look at our roadmap. So as I said before, we're trying to fill out all those boxes in the platform. So one of the things we're trying to do is we're trying to make it really easy for people to add components so that we can start filling out those boxes. And so adding a component is pretty straightforward. You basically take the YAML manifests for whatever package or product you want to deploy. So if you had something like Jupyter Hub or Argo, you would get those manifests. You then turn them into ksonnet. So that basically just means turning them from YAML into JSON. And then you provide us a PR. And then there's instructions that are linked from this presentation that go through the steps in more detail and provide some instructions on how to structure your ksonnet package. So we had our first 0.1 release at the start of April, and this basically has our core components. So these are the boxes that we sort of fill out right now. So we have our trainer, which is TensorFlow right now. We then have serving, which for serving you can either use Seldon or you can use TF serving. And then we have Jupyter Hub for some of the data analysis and ingestion pieces. And then we have Argo, but we're still missing a bunch of other components. So we'd like to get to a 1.0 by December, so end of the year, and hopefully in time for KubeCon USA. And we'd like at that point to be ready for production. The core CUJ that we're trying to be able to fulfill as part of our 1.0 release is continuous integration and deployment for machine learning. And so what this means in the context of machine learning is you can think about every night you get more data. So you can imagine if you're generating recommendations for a website like YouTube, you get new data in the form of web logs from your most recent events. You'd like to retrain your models using the most recent data, evaluate those models, and if those models are doing better in production than your current models in production, you'd like to push them automatically into production. So that involves a lot of additional components and functionality beyond what we have today, and we're hoping to get there by our 1.0 release. And I think there's an open question as part of getting our 1.0 release is whether we join a foundation like CNCF or possibly some other foundation. So we're targeting a 0.2 release at the end of this quarter, and we sort of hope to get into a release cadence of having a release every quarter. So in this release, we're hoping to have early versions of some new components. So KTIB for HP tuning, PyTorch for training PyTorch models. We'd like to have batch inference, Horvath integration. We're adding a central UI to make it easier to sort of navigate all the different components in Kubeflow. We'd also like to have an easier deployment story, so something closer to a click-to-deploy solution. And then in addition to that, we're making some improvements to our existing components, including a new API or a new version of the API for our TF job operator. So with that, I'd like to switch gears a little bit and try to talk about some of what I think are some core principles for Kubeflow. And so I think there's about 3 of them. So the first one is we want to be open. And I've already sort of talked about why we want to be open. It's because it's such a big problem that we're trying to tackle. We think being open is going to be critical to our success. And we also think that this is an important lesson to be learned from the Kubernetes community. What this means is from the beginning of Kubeflow, we've spent a fair bit of time trying to ensure that everybody within the community, so not just Google, who sort of kick things off, has an equal opportunity to take on leadership roles and other roles in the community. So from a logistical perspective, we've tried to give equal access to our test infrastructure, our release infrastructure, to external contributors, so not just Google. So there's really no difference between Google contributors and non-Google contributors. It also means that our success will depend on everyone carrying water and chopping wood. And so I think as we grow, this is one of the challenges that we face as a community. So as an example, the number of PRs per week is roughly about 2 times the number of commits right now. So we're not sort of keeping up with our velocity. So it's important for us to get more people to act as reviewers from the community so that we don't restrain our velocity by our review capacity. The second principle that we have is we want to have a low bar and a high ceiling. So a low bar means we want to make it super easy to get started with Kubeflow. And so one of the challenges there is we need to minimize the number of Kubernetes concepts and APIs that users need to learn to get started. There's a lot of data scientists and ML researchers that would like to use Kubeflow and start to get some of the advantages of Kubernetes. But trying to get up to speed on Kubernetes can really be trying to drink from a fire hose. Trying to make that as simple as possible and make it as easy to deploy Kubeflow without knowing too much about Kubernetes is a high priority for us. And this is a very active area in the community in terms of trying to figure out how to make the APIs more friendly and amenable to data scientists. By a high ceiling, though, we want to make it very easy for system administrators and people that are knowledgeable of Kubernetes to take full advantage of Kubernetes to do complex customizations. And so that's everything from configuring complex security policies or volume management. And then one of the reasons we want to do that is because we've seen from Kubernetes, we think that extensibility has been key to Kubernetes success. So we want to make sure that Kubeflow is very extensible and can be easily adapted to different use cases and not sort of limit what people can do with it. And finally, we want to be Kubernetes native. And so as I said earlier, we want to run anywhere Kubernetes runs. and we want to reuse Kubernetes concepts and APIs. Like custom resources are a perfect example of that. There's a lot of functionality and tooling in Kubernetes that makes it really easy to manage distributed jobs and sort of handle the mechanisms. So using the API server as for opportunistic locking. So we don't want to have to reinvent the wheel. And so because of that, we're sort of taking a hard dependency on Kubernetes because we're going to depend on that functionality being there in order to support the services that we're developing. So I'm going to talk a little bit more about how we're applying these principles. I already talked a little bit about how we're open, so I'm going to skip directly to how we're Kubernetes native. As I mentioned already, we're taking advantage of Kubernetes APIs and concepts like the custom controllers for TF job. But another principle there is that we don't necessarily want to hide Kubernetes APIs because we want to give people all the flexibility in Kubernetes. So as an example, the TF job operator, it contains the pod template spec so that if people want to specify things like requests and limits to control their job, they can do that and they don't have to learn a new API. They can also take up Kubernetes volume management system to manage data and attach data to their pods, as well as do things like inject secrets. The other thing that we're following in terms of Kubernetes is we want to make sure that Kubeflow and ML is managed declaratively, matching K8's best practices. And we'd like to embrace GitOps because we see that as gaining a lot of traction in the community and very powerful pattern. The other thing is we're trying to leverage the Kubernetes ecosystem. So as an example, we want to align with what SIGApps is doing in terms of the application CRD and try to leverage those ideas in terms of how we manage Kubeflow deployments and make that super easy. I think one of the challenges that we face in the community is, can we reconcile being Kubernetes native and having a low bar? So as I said before, Kubernetes has a very steep learning curve. And so if you're going to expose those Kubernetes concepts and APIs like we do in the TF job operator with the pod template spec, that arguably creates a barrier to data scientists, which sort of goes against our idea of being low bar. And so trying to figure out how to reconcile those two principles is an area of hot topic within the community. And I think one of the things that we'd like to avoid is having users fall off a cliff. And so what I mean by this is, when you get started with Kubeflow, you have some canned examples, like MNIST is the hello world of ML. And so you can imagine that we can package up the examples in a nice way so that you don't have to know Kubernetes to actually run the example. But then when you actually try to run your own models on your own data, suddenly you're dealing with things like connecting to your external storage systems, whether that's GCS or S3, and now you've got to deal with volumes and credentials. Now you have to deal with the logging system to try to figure out why your jobs are failing. You run into RBAC, and so suddenly to go from running the examples to running your actual jobs and doing ML, you have this huge cliff that you have to climb, or a huge mountain, in order to learn all the Kubernetes concepts that are going to allow you to be successful. And so I think that's one of the challenges that we face as a community. And so finally, why ksonnet? So portability is our mission, so we want to make it really easy to move ML solutions and ML applications in between different environments, so in between cloud and on-prem. And so we think the abstractions in ksonnet are very amenable to that. And so this slide sort of illustrates how you build ML applications out of ksonnet components, right? So at the start, you have in ksonnet, you have parts. And so individual parts correspond to manifests for Kubernetes resources, right? So you can imagine that if you're deploying a model in production using TF serving, you would have a manifest for your actual Kubernetes deployment object. You would then also have a manifest for the service, the Kubernetes service, that's going to direct traffic to this model. So when you combine these components into a logical or functional unit, in Kubernetes and ksonnet, that's called a prototype. So in this case, you might have a prototype for TF serving, and this is going to be parameterized by values that are going to specify things like your model location that you want to serve. So TF serving might be one prototype. You might also have a prototype for doing your training jobs. So you might have a prototype for your TensorFlow job because you need to train your models, and this will also have as a parameter the location where you want this trained model to be located. So when you're building an ML application, you create these components out of the prototypes. So you have your server for your model, and then you also have your trainer. And so when you combine these components, you get an ML application. So in this case, you might have an ML application that's doing something like predicting sentiment. And in this case, you might be using TensorFlow to both train the model and then TensorFlow serving to serve the model. But another application, like if you're doing title prediction for a GitHub issue, you might be using a TensorFlow trainer, but you might be using Seldon to actually deploy that. And so then once you have that ML application, you'd like to be able to move that application easily between different environments. So one environment would be on-prem, and another environment would be in cloud. And so one of the nice things about ksonnet is that you have an explicit concept of an environment. And for each environment, you can specify different values for the parameters. So like you could change the number of GPUs you're using in a particular environment, or the credentials you're using in a particular environment. And that makes it really easy to move an application back between different environments, so like your test and staging environment or your production environments. And so that's pretty much it. So if you'd like more information, our main repository is kubeflow/kubeflow. We have our community repository where you can find information about contributing to Kubeflow. There's our Slack channel, our Twitter handle, and then our mailing list. And with that, I'll open it up to any questions.
Thanks for the talk, really good. You said about simplifying it, so people don't have to climb that mountain.
Yeah.
Is there anything in progress around that, or any plans for that?
Yeah, so we have a Bootstrapper. We call it a Bootstrapper, and we're really trying to do two things with the Bootstrapper. One is we would like to try to get an experience where you can just sort of deploy Kubeflow using kubectl create-f from a manifest. And the other thing that we're trying to do with the Bootstrapper is we're trying to automatically optimize Kubeflow for your particular deployment. So we want to figure out what features you have enabled or on your Kubernetes cluster, and then take advantage of those features to customize it for your particular application.
Just a comment. Just a comment to this. We currently, I think, follow the pattern of creating a toolbox kind of container which you exec into, and you have whole tool set of managing Kubeflow inside, and Bootstrapper among other things. So, but this is very, as Jeremy mentioned, this is very, very open and very active part of our like a lot of things happen there. So if you have any good ideas, please help. We need the.
Do you want to wait for the microphone?
How well does it work for, like, let's say, multiple users on sharing the same cluster, running like various training setups for multiple models?
So you're relying on Kubernetes for all the resource isolation. So you get so obviously to the extent that if me and you submit two different TF jobs, you're relying on Kubernetes to schedule those jobs efficiently and ensure that we each get the resources that we requested. We don't have in Kubeflow, we haven't really started taking advantage of namespaces and other features like RBAC to isolate users to prevent different users from interfering with one another. There's a question back there.
Kind of an extension of what you've just described in terms of isolating users. In our use of Kubeflow, we had to isolate certain resources specifically P3 instances in AWS because of expense. Are primitives likely to get into Kubeflow to kind of facilitate that, or do you consider that to be outside the kind of role of Kubeflow in terms of allowing auto-scaling for pricing or isolating the kind of huge expense that can come if you leave GPU instances on?
I think we would like to work with the Kubernetes community to have those features land at the right level of the Kubernetes API and then find out ways that we can leverage them. So as an example, we haven't done that particular functionality, but one of the functionalities that we need in Kubeflow is batch scheduling. Gang scheduling, for example. And so we're taking advantages of things, I'm blanking on the name. But there's a scheduler project in Kubernetes to provide those advanced types of scheduling features. And so we'd like something similar to that for doing price-sensitive comparisons.
Yesterday there was a talk about running Spark in Kubernetes. Do you somehow see in the future that Kubeflow will be supporting Spark?
Yeah, we definitely want to support frameworks like Spark and Flink as an example. So in particular, TFX, they rely heavily on Beam. And so as part of having an open source solution that can run anywhere, we need to use some of the open source runners for Beam in order to run distributed on platforms that aren't GCP. And so we hope to take advantage of Spark and other support for running Flink on Kubernetes to provide that as a solution to our users. Okay.
So now the current use cases covers a lot like just the training model and serving the model. How much you see like data management being part of Kubeflow? Like you had it as part of the overall graph. Where do you see it on the roadmap?
So I think so in data management, I think a big desire from enterprises is auditing. So they want to make sure that understand like what code ran against which data. So I think that's an important feature to get integrated into Kubeflow. I think around that you have like data exfiltration protection. You have things like Pachyderm that are providing a lot of the data provenance features and reproducibility for data scientists, and that's one of the reasons we're integrating with Pachyderm. Okay, thank you very much.